Okay, so now what I wanted to kind of talk about is a summary like I have on the board. So basically, it all depends on where everything is. If you are outside the function, anytime you're outside of the function, that means the y values are getting changed. All right, so this number right here, that k number is up or down. Okay, this a number right here is going to stretch or shrink, and that right there should be an A right there. So let me correct that. Okay, so you want to get real clear in your mind how these things work, as we'll kind of summarize these things. Okay, all right, so plus K, up or down. Plus K is up, minus K is down. If A is bigger than 1, you vertically stretch. If A is less than 1, if it's between 0 and 1, you vertically shrink. Okay, that's what those numbers do. And again, if you're inside the function, I'm highlighting what's inside of the function. If you add to x, then that takes you to the left. If you subtract h, that takes you to the right. And then the number that you multiply by is always doing stretch shrink. And then if b is bigger than 1, you horizontally shrink. And then if b is between 0 and 1, you horizontally stretch. The thing that I want you to pay attention to, and I talked about this last time, is when you're outside the function, everything's logical. Plus is up, that seems reasonable. Minus is down, that's reasonable. If this number is bigger than 1, you're stretching because you're multiplying by something bigger than 1. If this number is a fraction between 0 and 1, you shrink. That to me is very logical, and I think students understand the outside aspects a little better than they do the inside. Once you're working inside the function, see, that's your function, you're inside, then it's kind of opposite. Plus h, that's that way, left. Minus h is that way, it's right. And then these things are backwards also. If b is bigger than 1, you horizontally shrink. So I want you to notice kind of how this stretch shrink works. If you're outside, a greater than 1 stretches. If you're inside, it shrinks. Those things are always opposites of each other, okay? So that diagram right there kind of summarizes everything except reflections, and then we'll kind of talk about how those things go also. All right, so I'm going to just kind of display what we have on here and kind of make some points on here. So if you look at this example number 1, the first thing we're looking at is just when we're outside of a function. All right, and then these are the transformations. So you can reflect over x, you can go up or down, or you can vertically stretch or shrink, okay? So if you look, I just tried to give you a couple of examples. Okay, so the number in front is outside of the function. What you would have here is that would be no reflection because it's positive 2. If it's negative 2, that reflects over x. So that number in front is what causes things to reflect over the x-axis. That's what that does. Okay, up, down. Look at my 2 examples here. You're outside. If you're adding 10, you're up 10. If you're subtracting 10, you're down 10. So you just got to know where the numbers are and how they cause the function to transform. Okay, here's how vertical stretch shrink works. Okay, if this number right here in front, you go down this example that I'm looking at right here, 2 is bigger than 1, so that stretches vertically by a factor of 2. 1/3 is a small number. It's a fraction between 0 and 1. Therefore, you shrink by a factor of 1/3. Okay, so that's kind of how that goes as we're doing this. And we're trying to summarize this as we go. All right, now let me just write something down before I move on here. I'm just going to make a couple of things up here. You can write these down if you want to, and just kind of see what we're understanding here, just on these aspects of the problem. Okay, all right, just want to check you on a couple of things. You can write them down if you want to, but you don't have to. Okay, look at the 2 things that are outside of the absolute value function. If you're outside, it's either making things go up or down, or it's making things vertically stretch or shrink. What does this minus 2 do? It's outside the function. Okay, down 2, right? Down 2. Okay, how about this second example I gave you? What does the 6 do? Up 6, okay, all right. Now, the number in front is going to cause a reflection or a stretch and shrink. Out of these two right here, which would cause you to reflect over the x-axis? That one. Why? There's a negative. There's a negative. So if you have a negative number in front of that function, it flips over x. The reason is the y values change. If you have a positive y, if it becomes negative, it flips over x. Okay? Now, we've got to think about this as stretch or shrink. You multiply by 2, y gets bigger. Does this stretch or shrink? Stretch. That's a vertical stretch by 2. How about this? You multiply by a half, numbers get smaller. So is that a stretch or shrink? Shrink. Okay, like that. So that's kind of how those numbers are. Down 2, up 6. That's the easiest for students to see. These numbers are just logical. Bigger than 1, you vertically stretch. A fraction, you vertically shrink. A negative causes you to reflect. Okay? So that's what we talked about there. Those are all of the transformations if you're outside of the function. Okay? All right. So let's kind of look at the next page. I just gave some examples of how graphs go on this. And then let's focus on the inside of function for a minute. Okay, so again, what we're looking at on this, there's 3 things that can happen. Okay, first of all, if there's a number inside the function, and let me zoom on this so I can kind of show you what I'm talking about here. I'm focusing on this number right there. Okay, that's inside the function. So again, what it does is the one that has a negative causes you to reflect over the y-axis. Okay, so you're inside the function, it's x that's changing. Okay, if that's a positive 3, there's no reflection like that. Okay, so now we're reflecting over the y-axis. All right, okay, left, right. Okay, this is kind of what we're looking at here is this -7 and that +7. So you're inside of the function, you're with the x, -7 takes you to the right 7, +7 takes you to the left 7, like that. Okay, everything is totally backwards when you're inside the function. Okay, and then the only other thing that's possible is this, and this is going to be this number right here is going to work like this. Okay, now that's right inside with the x, and it's backwards of what you think. It's backwards of vertical. So when you multiply by 3 inside the function, that causes you to shrink by the reciprocal. And we talked about that last time. The reciprocal of 3 is 1/3. So we call that a horizontal shrink by 1/3. Okay? If this number is 1/3, is a fraction between 0 and 1, that says strength. I don't know why I put that on there. Scratch that out and make that stretch. So that it would be a horizontal stretch by 3/1. Okay? So the horizontal, the things inside, are always a little trickier for students. So there's that would be left 7, that would be right 7. The sign tells you. Does that make sense? It's inside the function. Adding 7 makes you go to the left. Subtracting 7 makes you go to the right. Okay?
They're both boxes on ours.
Say that again.
They're going to the wrong one.
I can't hear you.
I'm trying to see.
Oh, you have trouble seeing because I'm highlighting, or is it just on here?
On page 5.
Oh, okay. All right. So if you get down here, then this number is inside the brackets. It's inside the function. So since it's bigger than 1, you horizontally shrink by the reciprocal. Okay, and that makes sense. You shrink by a fraction. It's less than 1. That's 1/3. That's going to cause you to stretch by 3/1. Okay. So I'm going to try to kind of see if we're beginning to put this together, and then we'll kind of do some graphs. Let me write down a couple of examples here. Just kind of, and I'm going to use like an absolute value thing here. Let's see, I'll kind of give a couple of little issues here. Okay, so this is ultimately what you guys are trying to learn. Okay, look at the things that are outside. On this example, 2 and 2 are outside of absolute value. What does the -2 do, first of all? Down 2, good, down 2, okay? On this next example, what does the +7 do? Up 7, Okay, that's what that number does. Now, what do these numbers here do? They vertically stretch or shrink. This number's bigger than 2, so does it stretch or shrink? Stretch. When you're outside, you're multiplying y by 2. If you multiply y by 2, y gets bigger, therefore it stretches. Okay? Same thing here. Don't disregard the negative. That would be a stretch also because it's bigger than 1. Okay? What does this negative do? Okay, it reflects over the x-axis. Okay, it's over the x-axis, so that's how that goes. Those are the two numbers that are outside. Now, if you look inside, we've got -1 and 2. We got +5 and -5 like that. So here's how it works. What does the -1 do? Right 1, good. On this example, what's the +5 do? Left 5. Okay, that's how that goes. All right. Now, this right here is backwards of this number. Okay, what that does is it's bigger than 1, so it's a horizontal shrink. This one also is a horizontal shrink. Okay, the fact that this is a negative, that reflects you over the y-axis. Okay, so what I usually find in teaching this, students are very solid with up, down, and they're usually very solid with left, right. Okay, it's generally the stretch shrink where the problems start arising. Okay, is there any question on that? I mean, you just got to get it really solid what those numbers do. And I think when you start doing graphing, it probably will make a little bit more sense because you'll see the y part a little bit better. Okay, so what we're going to do on the next couple of pages, I'm going to do one problem that where you're doing a graph and you're trying to put it all together. Now in class, you guys have done a lot of graphs, but we were usually doing just one transformation at a time. What we're trying to do now is try to put this all together. All right, that's the attempt. Okay. All right, so first of all, we're going to look at everything in the function and just kind of identify. The elementary function, because we have a second power, is going to be y equals x squared. So you want to write that down. That's the function that we're going to do there. Okay, look at the function I gave you. What do you think about left, right? Right 3, good. Okay, so it's this number right here is what's going to cause that to go to the right 3. So you want to write that down. Okay, you got to be solid on that. You're going to the right 3. Okay, all right. Now we're going to look at stretching and shrinking. Okay, so let's start by looking at this number. That's the one that's outside. If it's outside, it's vertical. Okay, so that makes y get bigger. Does that vertically stretch or vertically shrink? Stretch. Okay, how would you make it shrink? You'd have a fraction there. You'd have like a half there, right? So that is a vertical stretch. So you want to write that down as a vertical stretch by 2. Okay, don't worry about the negative 2. That has to do with a reflection, okay? All right, now the horizontal is here. Okay, it's that number right there is causing it to be horizontal. Okay, so is that a horizontal stretch or shrink? Everything's backwards when you're inside. That's a stretch. It's a stretch by the reciprocal. So we're going to say horizontal stretch by 2/1 like that. So you say by the reciprocal. Now see, when you do the reciprocal, then it's logical. Okay, we're making it bigger by a factor of 2. Okay, so that's how that goes. Okay, now we've got to figure out where the reflection is. So which number in this problem makes this thing reflect? You just look for a negative. What is it? Exactly, the -2. So this thing right here, the fact that that's negative, causes you to reflect vertically over the x-axis. So what we would say here is we would reflect over x. Okay, you can't get that backwards. The reason it's over x is because it's making y become an opposite. Okay, that's how that goes. Now, where would I put a number to make this thing reflect the other way? Where would the other number have to be if I wanted to make it reflect? Right there. If I put a negative there, then it would make it reflect over the y-axis. Okay, that's how that works. Okay, so that's kind of putting all of the possibilities together. So on this, there is nothing, there's none there, so we don't have that. Okay, now, how about up or down on this problem? Look at the original. What do you think on that? Which number do you look at? The 4, right. So that plus 4, or does that tell you we're going up or down? We're going up, good, okay. All right, so that's the first thing you have to be solid on, is you got to know what all of those numbers do. And I've kind of got a little diagram on the board that you can refer to if you need to. Okay, now there's different ways to teach students how to do this. When you're doing a problem where you put this all together, I'm going to teach you how to do very simple arithmetic to get the graph in just a few steps. And ultimately what you're learning for higher math is how numbers affect functions. That's real important in calculus and pre-calculus, trigonometry. You've got to understand how these numbers affect a function. Okay, so you do this in a certain order. This is real important. You always start by doing left, right first. Then you do your stretch, shrink kind of together. Then you do your reflections. Then you do your up and down. There's kind of an order of operations to that. And the reason you're doing this is it's order of operations. Left, right is inside parentheses. You always, when you do arithmetic, you start inside of parentheses. So you start there. And then the last thing you do in order of operations is add. So right there. Now the stretch, shrink are all kind of done together. Stretch, shrink, and reflect can all be done in the same thing. So when you transform your graph, you're going to go right 3, then take care of your stretch, shrink, and your reflection, then up 4. Now, it's very hard for people to keep track of this without kind of writing down what you're doing. So when I have you put together a chart, here's kind of the idea. So to begin with, we're going to do the elementary function. So right here, we're just going to square all these numbers. And you guys did a bunch of this in class with elementary functions. So you're taking -2 squared, so that'll be 4. You're taking -1 squared, that'll be 1. 0 squared is 0. 1 squared is 1, and then 2 squared is 4, like that. So that is your elementary function, and you want to graph that on the graph that I provided for you. So go ahead and plot those points. So you have -2, 4. You've got -1, 1. 0, 0. 1, 1, and then finally 2, 4. Okay, and then just kind of lightly dash that in, and then label that as y equals x squared. Okay, so we have done, I think the last couple of classes, we did a lot of work with just doing an elementary function. Okay, so we're squaring. Okay, all right. Now, here's what we do first of all. Now, the very first thing that we do is we said in this problem we're going to the right 3. Okay, we're going to the right 3. So here's what you're going to do. You're going to make the x value go to the right 3. Okay, and what you're going to do is you're going to leave y. You always just do something, leave something alone and the other one changes. So go ahead and just write your y values down. Okay, that's 4, that's 1, that's 0, 1, 4, so you want to go ahead and do that. Okay, now you do this in your head. You don't have to really show your work. But what you're doing is you're doing -2, and if you're taking this to the right 3, you're doing -2 plus 3, so that becomes 1. Okay, just moving that -2 to the right 3. Then you do -1 plus 3, and that'll give you 2. And you'll start seeing a pattern on this, okay? The next one you do is like 0 plus 3, so that's 3. And then you see a pattern. You're just going to go the next one. 1 plus 3 is 4. 2 plus 3 is going to be 5, like that. Okay, so when we move something to the right, we're just making the x value get bigger by 3, right? If I was making it go to the left, I would subtract numbers from it. Okay, are you guys with me? Okay, all right. Now we're going to do the stretch shrink, and we're going to do this all together. So basically this works kind of like this. If you look at what we figured out we have a vertical stretch by 2. Okay, so I'm going to kind of write a little note to myself. When you do a vertical stretch, what you do is you multiply, and you want to write these little notes to yourself on here. It's a vertical stretch, so you multiply y by 2. Okay? So that's, if you go back and look at the original problem, that's what it said, is that you had that 2 in there. Okay, now watch carefully how I do these things now, and you can do these all in your head. You're multiplying all of these y values right here. I'm just going to kind of highlight those in yellow. Now just multiply them all by 2 in your head. 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 4 times 2 is 8. That's how you vertically stretch something by 2. You multiply it by 2. Okay? Okay, if you know what to do, it's easy arithmetic. Okay, now let's do the other one. The other one we had was a horizontal stretch by the reciprocal. Okay, if you look at the original problem, there was a 1/2, so you multiply by the reciprocal. Okay, so one thing I'm going to write as a note on here is that your horizontal stretch that we figured out, the horizontal stretch, you multiply x by the reciprocal of 1/2, like that. Okay, the reciprocal of 1/2 is 2/1, right? So I'm going to highlight the x values in blue here, and you're going to do the same thing. In your head, multiply the x values by 2/1. So 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10, like that. Okay, always do the reciprocal on the horizontal transformation like that. Okay, so we're figuring out where these points are going to go to. Okay. All right, now when you look at reflecting, we reflected over the x-axis. So when you reflect over the x-axis, the way that you reflect over the x-axis is make y opposite. So we're going to make y become opposite, or maybe I'll just write it like this. When you reflect over the x-axis, you multiply y by -1. Okay, so that's kind of how I do this. I'll try to highlight to kind of show you what I'm doing. When you reflect over x, the 8 needs to become -8. The 2 needs to become -2. And you just do this in your head. Just multiply each of those y values by -1. So that's going to be -8, -2, that's still 0, -2, -8. That's how it reflects over y. Okay, now what you're going to do here is you're going to keep x, because we're not reflecting over the y-axis. So the numbers you see in the previous step, 2, 4, 6, 8, 10, they're still the same. Okay, like that. Okay, so if you can identify what the numbers do and know the order of operations of doing your transformations, then you just kind of follow this procedure. Okay, so the last thing we did was we did up 4, so that's going to add 4 to your y values. Okay, and that's why you're going up, is because the y values get bigger. Okay, so let's see, I'll kind of highlight this in a color right there. These y values that I'm kind of highlighting in that purple, just in your head, add 4 to the y value. Okay, so we're going to do like -8 plus 4. Now that's -4. We're going to do -2 plus 4. That's going to be 2. Okay, then we do 0 plus 4. That's going to be 4. Then we do -2 plus 4. That's 2. And then finally we do -8 plus 4 again. So that'll be -4. Okay, so that's how you make something go up, is you make the y values get bigger by 4. Okay, the x values stay the same. When we're not doing left or right, we're doing up or down. So just bring down these x values from the previous step, which were 2, 4, 6, 8, 10, like that. Okay, then I'll show you what we're going to do with this. And I'm going to kind of review what I just talked about here. Is if you kind of looked at left, right, see, here's the original points. Okay, if I made this go right 3, what did I do? I made these x's get bigger by 3. 2 plus 3, 1 plus 3, and so forth. Okay, that's step 1, is to do the left, right. Well, I did the stretch shrink. Okay, we had a vertical stretch by 2, so I multiplied by 2. 4 times 2 is 8. 1 times 2 is 2, and so forth. We had a horizontal stretch by 2 over 1, so we multiplied 2 times 2 to get, wow, did I do that?
5. 2 times 5.
Oh, I'm sorry, 2 times 5? Oh, hold on, let me see what that original problem was here. Oh, yeah, okay, we're doing 5 times 2. Sorry. Okay, I'm confusing myself, okay? 5 times 2, 4 times 2, 3 times 2, like that. Okay, so that's what we did. Okay, now when we did reflect over x, well, what did? We changed all these y's to opposites. Okay, and then finally we had the up 4, so I just did -8 plus 4, -2 plus 4, and so forth. So if you know what those transformations are doing, then if you run through this system, and then you're going to get your new function. So here's what I want you to do to wrap this up then. And then I'm going to let you try to do a problem. I'll give you a little time to see if you can do this. So just plot this last group of points, and this will give you the new graph. Okay, so just start off with 2, -4. Then you're going to have 4, 2 over 4 up 2. Then we're going to have 6, 4. And then 8, 2. And just kind of add a number 10 in there. Then you're going to go 10, -4 like that. All right, and this is what that new transform graph looks like. Okay, so I want to kind of, when you plot those points, we now want to go over and kind of see what happened on the problem. All right, I'm going to make a little screenshot of the function too, and then I'll come back and do this and just. So let me make a screenshot of the function because I want to show you kind of what happened on the problem. And then I'll come right back up here and display the rest of it here in just a second here. But I just want to show you all something on this and see if you can see what really happened on the problem. When you do a problem that has a bunch of transformations, it's hard to keep track of it. All right, so let me show you something. Just look at the graph that we just drew, and let's kind of see how this related. Okay, we went right 3 up 4. Okay, let's see if we see that. Let's start here. Right 3, 1, 2, 3, up 4, 1, 2, 3, 4. Okay, so we kind of got that right there. Okay, and we moved over because of the stretch shrink is what affected that. Okay, so we kind of did the movement over and up. And then what did this thing do? What did that negative do? It flipped it over. Okay, so it flipped it upside down. That's what that did. Now, basically, it's hard to see on this problem is how the stretch shrink, but doesn't this thing look like it's a little wider? Okay, so it did kind of stretch and shrink that way like that. Okay, so basically, by doing that arithmetic, it gives you a way to keep track of everything. It's really hard to do all of these transformations in one step. Okay, any questions? To me, out of the things that we're kind of working with in this section, these are some of the harder things to learn here, but they're really important for higher math. So what I want you all to do, and I'll come around and help you, and you probably should really work together on this so you can kind of see how you're doing. We have this function. So this is an absolute value function. Okay, so your elementary function is just y equals absolute value of x. So I'll walk around. I want to see if you can identify the transformations. And then I want you to work a little bit on your table. Let's see how we do. Okay, I'll give you about 10 minutes to do this because there's a lot going on in the problem. Okay. So before, I want to kind of see your transformations. I want to kind of just see what you're thinking of there. Let's see if I see anything wrong there. Yeah, okay, so you come right, okay. Okay, yeah, you got it, okay. Get the transformations, and let's get it started. Okay. Good, okay. What you got left, okay. And what you want to say is shrink by. Okay, so like you're going to vertically shrink by 1/2, and you horizontally shrink by the reciprocal of that number. Very good. Okay, then you're good. Okay, so you got it. Okay. Now, when you do horizontal, you want to shrink by the reciprocal of that too. So you shrink by 1/2. Right? All right. So you know, well, you get your hand out. Right? Yeah, that the number out front is, you know, multiply by a fraction and shrink it vertically. This number, you
have to, it's by the reciprocal.
Right, you shrink by 1/2. There you go. Yeah, okay. Very good so far. Okay, what have you got so far? Okay, so you got to know which way. Okay, that right there is telling you to go well. Okay, you're correct. You're shrinking there. You do want to state what it is. You got to state that it's a shrink. The reason it's a shrink is because that's a fraction. It's less than 1. Horizontally, you're always doing the reciprocal of that number. So we would say shrink by 1/2. Do that, okay? And there's no negatives, there's no reflection because the 2's not negative and the 1/2's not negative. And then you got the down 3 of it. Okay? All right. This one is the one that's backwards of that, okay? This is the number that causes the horizontal stretch shrink. You work with the reciprocal. So that really would be a shrink by 1/2. Yeah, you'd say shrink by 1/2. See that when you're outside the function, it's just the same. You shrink by 1/2. Okay? This one, it's really, you're working with the reciprocal, and since it becomes 1/2, that's why you shrink.
So we
You're going to multiply both by 1/2. Both by 1/2. I think the problem that I did before, we ended up having stretch by 2 on both of them, so we doubled both of those formulas. Okay. Got that. Now this part right here, the shrink horizontally is that number right there. And you do the reciprocal. So that you want to say is shrink by 1/2. That number right there is one that you want to kind of maybe make a note to yourself that that's the one that you're working with the reciprocal of. This means turn it upside down. So 2/1 becomes 1/2. As far as reflections go, that number would have to be negative to cause a reflection over y. That would have to be negative 1/2 to make it reflect over x. So there is none. Yes, there's none. Okay, you got that okay. And let's see if you can kind of put the numbers together and you can compare how you're doing. All right, okay, we all got our transformations okay, so I'll let you kind of see what you get on your table here. And you're going to get some some fractions on these problems. So you can use decimals if you want to when you start doing the stretch shrink stuff. And if there's no reflection, which, you know, where there isn't a reflection, so that step 3 in your points isn't going to change anything from step 2. We're good. So let's kind of see how this goes now. I'm going to look kind of at your last row. If you got your last row, you did it right. What I'm seeing is, now you have a 1/2 right here? Mm-hmm. Yeah, so 1/2 minus 3 would be negative 5/2 or negative 2.5. So see, that should be negative 2.5. And same thing with that. Then they're right. That's all you did. You just made one little tiny arithmetic mistake. Okay, let's see your last. I can always tell if you did it right based on the last row. Yeah, okay, so you can kind of see how it moved, the original moved left and down, and if the horizontals, if they both horizontally shrink at the same factor, then nothing happened really. You know, it's just kind of ends up, it kind of balances everything out, right? Okay, good, good. That's -1. That just stays the same because all you were doing in this up down was just the y's, the x's come just copied down. They don't change. That's it. Okay, so I think you have a good graph. So this step right here, in this first step, yeah, you're keeping y. But you're going left 4. -2 minus 4 would be -6. So you're really making the x's go down by that factor. Okay, now you may have missed what we were talking about, so you may need to come in and kind of get with me in my office. Okay, because I mean we spent the last couple of classes on that. So I'll let you kind of get things copied down. You could maybe work with him or Alvin out there just a little bit and kind of see what he's doing. Yeah, you got it. Okay. Very good. And really all you got to do on your graph is just the original and the final. You don't have to do the intermediate. Because if you do that, it's kind of hard to see what you're doing. Yeah. Okay, so let's see. What the first thing is we were going left 4. So this you need to do -2 minus 4 to get -6. -1 minus 4 to get -5. These numbers are getting smaller by 4. You move to the left, it's the x value that changes. So you've got to adjust that first step there. Okay? Okay, you got it. Okay, and just plot it, and then you'll get a good graph. Okay? You did everything, all the transformations the right way. Okay, so on the left part, so we said left 4. Left makes x change. X is the first number. So if you're going to move -2 to the left 4, it's going to end up at -6. Well, no, you did this okay. The absolute value, that's your elementary function. So you want to plot those points and kind of have that in a dashed line. Okay? And then these numbers, when you move left, the x values move to the left 4. So like if you had 2 moves to the left 4 is going to be negative 2. Okay? The y stays the same on step 1. Okay? And you do that. So when you're moving left 4, you're just doing negative 2 minus 4, negative 1 minus 4, 0 minus 4. Yes, absolutely. Left is what makes it, subtracting is what makes it go to the left. Right? Okay, yeah, that looks okay. And if you look at, the original, let's see, left 4, down 3, you can see you did that. There was no reflection. And the reason it didn't really stretch or shrink is because they both shrunk. And if you shrink vertically and horizontally by the same factor, nothing changes. That's kind of what happened on the problem I did. It just kind of coincidentally that did that way. So you got all the arithmetic right on that then. Okay. Yeah.
Can you show me how to get the number into a fraction on the calculator again?
Yeah, just give me a second here. Okay, so I went through and kind of carefully checked what we had on this. Everybody had the correct translations, so that's good. Now, really what you got to kind of do is just check on your paper. All I did was check your last column. If you had the last column right, then you had to do the entire thing correctly. So what I was looking for is that you graphed your elementary function. That's the first row, which is the absolute value function. And really what happened on this problem's pretty easy to see actually. If you look at the original function, you moved to the left 4, 1, 2, 3, 4, and then you went down 1, 2, 3 like that. Okay, so I've got like the points just ended up, I don't know if I had put that thing in there right or not. So let's see, we have negative 3, negative 2, I've got that, negative 2.5 and so forth, and then negative 2, negative 3 is where that kind of lower point like that goes. Okay, so that's how that would work out. If you do all those transformations correctly, that's how that works out. Okay, so you want to kind of get these corrected. I tried to do this, so we did left 6 or left 4. The x values went down 4. Stretch shrink, we really cut both numbers in half. There was no reflection. And then the last step was to move all the y's down 3. So that's what you want to do. Okay, so let's go ahead and take our 10-minute break now. And when we get back, we'll work